Good morning everyone. I am Priyanka Fulsandar, Assistant Professor IT Department. In my previous video, we discussed about number system conversion. In that, binary to decimal conversion and decimal to binary conversion we already discussed. And in this video, we discuss about octal to binary conversion, hexadecimal to binary conversion. Also, we discuss decimal to octal conversion and so on. Now we will discuss one by one. Now first we discuss octal to decimal conversion. Now first step is that write the given number. This is our octal number. Okay. And second step is that write the positional weight for each digits. Here we write positional weight, that is 8 raised to 0, 8 raised to 1, 8 raised to 2. It's right. Our second step is that write the positional weights for each digits. Now our third step is that multiply each digit in the given number with its corresponding weight to get product of digits or positional value. So here third step is that multiply digit into weight. So our digit is 7 and our weight is 8 raised to 0. So 7 into 8 raised to 0. Here same as it is. Our digit is 5 and positional weight is 8. So we multiply 5 into 8 raised to 1 and so on. This is our third step. Now our fourth step is that find the sum of product to obtain the decimal equivalent of the given octal number. So our fourth step is that sum of product. So here 7 into 8 raised to 0, that is 7, 5 into 8 raised to 1, that is 40. Here fourth step is that it's our sum of product. So our final answer is 239.25. Base 10. It means it is an octal number. It convert to decimal conversion. Okay. Now the second conversion is that decimal to octal conversion for integer part. To convert a decimal number to an equivalent octal, the integer part of the decimal number is converted to octal successive division by 8, and the fractional part of the decimal number is converted to octal by using successive multiplication by 8. In the successive division by 8, the integer part is divided by 8 till the quotient reaches 0, and the remainder to the division is the MSB. To obtain the equivalent octal integer, the remainder are read from bottom to top. Remainder are read from bottom to top. And in successive multiplication by 8, the fractional part of the decimal number is multiplied by 8. It means that till the fractional part of the product is 0. So the equivalent octal fractional part is obtained by reading the integer from always top to bottom. It means MSB to LSB. Finally, the result is combined to obtain the equivalent octal number. Now see in this example, this is our octal number, that means 128 to the base 2. It is our decimal number. Now this decimal number we have to convert into the octal part. So first step is that write the decimal number. Here we write our decimal number, that is 128. Now second step is that divide the decimal number by 8. Here we write our decimal number divided by 8. And the remainder obtained is the LSB of the octal number. This is remainder is obtained is the first remainder, that is LSB. Okay. Now third step is that divide the quotient obtained from the step 2. Divide the quotient obtained from the step 2. And the remainder obtained is the second LSB of the octal number. Remainder obtained is the second LSB of that octal number. Okay. And last step is that repeat the division by 8 till quotient become 0. Till quotient become 0, repeat this step. For example, quotient is no longer divisible by 8. And the last remainder obtained from the division is the MSB. Last remainder obtained is nothing but the MSB of that particular octal number. The equivalent octal number is read from bottom to top. Always remember, equivalent octal number is read from bottom to top. Now here is our answer, that is 128 to the base 10, and our answer is 200 to the base 8. Okay, it means that we convert decimal to octal conversion. Now we discuss decimal to octal conversion for fractional part. First we discuss decimal to octal conversion for integer part, and now we discuss decimal to octal conversion for fractional part. So our number is 3.3125. So our first step is that write the fractional decimal number. So here first we write our fractional decimal number. Second step is that multiply the fractional decimal number by 8. Here we multiply fractional number by 8 and write the carry in an integer part. So our carry, here is the final product and write the carry in an integer part. The first carry is nothing but your MSB. Now second step is that multiply the fractional part, multiply this fractional part of the product that is obtained in step 2 and record the carry. So multiply this product into base 8 and obtain your product. And repeat the step 2 and step 3 till the fractional part of the product is not 0. The last carry is the LSB of the equivalent octal number, and the equivalent octal fractional part is obtained by reading the integer from top to bottom. It is always reading by top to bottom, that is MSB to LSB. For integer part, it obtains LSB to MSB, and for fractional part, MSB to LSB. Now our answer is that 0.25. It means 2.24 to 4. Okay, so it means that we convert decimal to octal conversion. Now we discuss octal to binary conversion. Now octal to binary conversion, here are some numbers, octal number and their binary equivalent number. Octal digits, that is 0 to the base 8, and here 3-bit equivalent binary number to the base 2. It means for 0, 3-bit binary equivalent number, that is 000 and so on. So this is our example 456.732. In this example, so first step is that you have to write the given octal number. So here we write our given octal number. Now second step is that replace each digit, octal digit, by its 3-bit binary equivalent. So our first digit is 2. So here 2-bit binary equivalent number is 010. So here we write 010. Now our next bit is 3. So we write for binary equivalent 3-bit. So for 3011 here and so on. So this is our binary equivalent. This is our final answer. It means that we have to convert octal to binary number. Now we discuss binary to octal conversion. So from binary to octal conversion, first step is that this is our example. In that this is our binary number. So first step is that write the given binary number. Here we write our given binary number. Now second step is that starting from either side of the binary point from the group of 3 bits. Okay, we write group of 3 bits. Here 1 0 0, it means first 3 bit, then next 3 bits, then next 3 bit, group of 3 bits. This is our second step. Now our final step is that replace each 3-bit binary group with its equivalent octal number. So for 100, binary bit is nothing but 4. For 101, binary is 5. For 111, binary number is 7. So our last step is that octal equivalent of 3-bit binary number. So our answer is that 457.273 to the base 8. It means nothing but we have to convert binary to octal. Now the next conversion type, that is hexadecimal to decimal number. So this is example 3a.2f. How to convert the hexadecimal to decimal conversion? In that our first step is that write your hexadecimal number. So first we write 3a.2f. This is our hexadecimal number. Now our second step is that write the positional weight for each digits. So here we write positional weight. For a, hexadecimal to decimal format is nothing but 16 raised to 0. For 3, 16 raised to 1. Here we write positional weight. Now third step is that multiply each digit in the given number with its corresponding weight to get product of digits or positional value. So third step is that multiply digit into weight. So here we write for a 10 into 16 raised to 0. For 3, 3 into 16 raised to 1. Here as it is same. Now our fourth step is that Find the sum of product to obtain the decimal equivalent of the given octal number. So here 10 into 16 raised to 0, that is 10, 3 into 16 raised to 1, that is 48. So final answer is 58, and here 0.71. So here our final answer is 58.71 to the base 10. It means that we have to convert hexadecimal number to the decimal format. Now we discuss how to convert decimal to hexadecimal number. In that, to convert a decimal number to an equivalent hexadecimal number, the integer part of the decimal number is converted to hexadecimal by successive division by 16, and the fractional part of the decimal number is converted to the decimal by using successive multiplication by 16. So, in successive division by 16, for the integer part, here convert decimal to hexadecimal for integer part. In that, it is divided by 16 till the quotient reaches 0. It is divided by 16 till the quotient reaches 0, and the remainder to the division is the MSB. Remainder is nothing but MSB. Remainder is nothing but your MSB. To obtain the equivalent hexadecimal integer, the remainder are read from bottom to top. Always remember, remainder are read from bottom to top. Now, in successive multiplication by 16, the fractional part of the decimal number is multiplied by 16. For the fractional part, it is multiplied by 16 till the fractional part of the product is 0. It means that the equivalent hexadecimal part is obtained by reading the integer from top to bottom. It means for MSB to LSB, and finally result is combined to obtain the equivalent hexadecimal number. So, to convert the decimal to hexadecimal for an integer part, first step is that write your decimal number. Here we write our decimal number, that is 2156. The next step is that divide the decimal number by 16. So we divide the decimal number from 16, and the remainder obtained is the LSB of that particular hexadecimal number. Now the next step is that divide the quotient obtained from step 2. So here we divide the quotient that is obtained from step 2, and the remainder obtained is the second LSB of the hexadecimal number. So remainder obtained is the second LSB of that particular hexadecimal number. Then repeat division by 16 till the quotient becomes 0, and for example quotient is no longer divisible by 16. So the last remainder obtained from the division is the MSB. So our last remainder is MSB for that particular hexadecimal number, and the equivalent hexadecimal number is read from bottom to top. It is read from bottom to top. So our answer is 863 to the base 16. It means that we convert decimal to hexadecimal format. Now we discuss convert the decimal to hexadecimal for fractional part. Our fractional number is 0.678. So our first step is that write the fractional decimal number. Here we write our fractional decimal number, then multiply the fractional decimal part by 8. Multiply the fractional decimal part by 8 and write the carry in the integer part, and the first carry is your MSB. First carry is your MSB. Now next step is that multiply the fractional part of the product obtained in step 2 and record the carry. So you have to record the carry. Now our last step is that repeat step 2 and step 3 until the fractional part of the product is 0, and the last carry is the LSB. Our last carry, that is LSB of the equivalent hexadecimal number, and the equivalent hexadecimal number fractional part is obtained by reading the integer from top to bottom. It is reading by top to bottom, that means MSB to LSB. So our final answer is that 0.ACCC to the base 16. It means that we have to convert decimal to hexadecimal number for the fractional part. So in this video we discuss about how to convert the octal to decimal, then decimal to octal. Also we discuss octal to binary and binary to octal, and decimal to hexadecimal conversion. Thank you so much for watching this video.